let's discuss on what is SSH. SS stands for Secure Shell. It's a network cryptographic protocol. If I try to explain you what is protocol, you can think of it as like a set of rules over network, which is a cryptography. So cryptography is like encryption and decryption is cryptography. Okay, sort of, not exactly, but yeah. It is based on like a client server model. So if it is based on a client server, there needs to be something running on the server which our client can connect to. So on server there is a SSH daemon running, which our SSH client, in our case it will be like terminal. Mostly it is terminal, but you can install anything, which will start a connection to the SSH daemon on the remote server to initiate the connection and talk to it securely using the cryptography. Okay, so what is the use of it? So it is mainly used for like administrative purpose, but you can incorporate it at any other places as well if you think so. But mainly its focus is to log to a remote login to a remote host, and if execute some command there for like management purposes, admin purposes. Okay, the preparation phase of the SSH. But before moving into that, let's look at if I have to connect to a remote server, how will I do it? So you must have seen like two approach. One is like SSH server IP, and another is like SSH user at the rate server IP, right? So why is this user required here? This in the case when the local username in your like Linux or Mac does not matches your remote username. Okay, so then you need to add a user which should be at a remote host. Now, and this is like if it matches, so no need to provide that. But after you enter this, you might end up with two situations. It might ask you for a password and it might not ask you for a password. So if it asks you for a password, that means like your key-based authentication is not enabled. I will highly recommend to enable the key-based authentication. The reason being, so if it is password, so it can be crackable using brute force bot algorithm, like who can just brute force all the password and try to crack it and get your access. But if it is not asking for your key or a password, so that means your key-based authentication is enabled. Okay. Now, before moving further, let's look at like suppose if I have to do the setup from start to like set up all the SSH environment. Okay. So before moving to that, I mentioned in the start, right, SSH is a cryptographic protocol. So where is the cryptography involved? I will come to that. If you have heard of this public cryptography or asymmetric cryptography, this may sound familiar. If not, I will recommend to go read about it. I might talk, but not as this video is not about cryptography, so it will be like very minimal. Okay, so let's look at the client side first and then server, as it's a client server model. Okay, so SSH provides us a tool called SSH keygen, which we can use to generate a public key and a private key pair. So this public key pair, as its name says, it's public, it should be shared to the server. Okay, so how I can move this public key to a remote server? So there is a command called SSH copy, which we can use, or we can just copy, and if I have access to the remote host, I will just go there and add a ID RSA public key here for user one corresponding. Let's say I'm a user one. Okay, but I will not share this ID RSA one. This is a private key. Okay, now let's look at the known host. So I will come to this later, but think of it as like known host is like an public key for a remote host to which I will log in through SSH. So it is populated, like it is not pre-populated, it is populated on demand basis. Okay, on demand basis. Now let's look at the server side. Similarly, server also has like a public key and a private key, which is generated again through SSH keygen, and it is stored as SSH host RSA. RSA is like an algorithm which is used for encryption. It can be RSA, DSA, and any other encryption which you choose, and if it is supported by like a keygen tool. Okay, and these are the authorized key. This basically stores the public key for all the user who has an or who is basically eligible to connect to this remote server. Since we have looked into the preparation phase of an SSH, now let's look at the execution phase of SSH. Okay, so when a user does SSH user at the rate IP address of server, what happens behind the back? Okay, so this SSH thing initiates a connection to the remote host. Okay, now remote host and local host like Alice basically is trying to come to a symmetric key which they will use for future encryption of their traffic. Like all the commands, all the instruction will be sent and they will be encrypted with this symmetric key. So in order to exchange the symmetric key, they are using like Diffie-Hellman algorithm. So Diffie-Hellman is a key exchange algorithm. Like you can exchange a symmetric key over a public channel. Okay, so unsecured channel. So now symmetric key is exchanged between the user. So now remote host will send his public key identity, which is server host RSA pub key. If you remember in the previous, like we have discussed this. Now user will basically check, the client will basically check if I know this host. So it will check in the known host. If it does not, it will prompt a user to basically identify and add it to the known host list. Then it will add in the known host list. As I mentioned, like it is not pre-populated, it is populated on the prompt basis, right? In the client side, if you remember, we discussed, right? So now public key is added, then server will basically decrypts, and once the public key is added, user will basically send a message with encrypting with the public key. Okay, now server will decrypt it with their private key. So this is like a public key private key cryptography, and this private key is basically server host RSA key, not the pub one. Pub one was used to send to the local host. Now in this way, Alice has basically authenticated the server. Alice authenticated server. Now the turn is for server to authenticate Alice. So now Alice will basically send his public key. Server will basically check in his authorized key. If he find that user in his authorized key, it will further move the connection. Otherwise, it will close the connection. If it is not present in authorized key, the connection will basically close and Alice will not be allowed to access the remote host. So if it is present, now remote host will create a message and encrypt it with public key of Alice. Okay, so now since Alice has a, and this public key is basically ID RSA pub. Okay, now since Alice has a private key, he can decrypt it and basically send it back. So now server will basically say, okay, I have received the response with the correct message. So he has authenticated to Alice. So now if you see, like there is a mutual authentication. Alice authenticated host, like remote host, and like remote host authenticated Alice. Now since both have authenticated each other and they also have a secret key which they have exchanged earlier, now they will use that secret key for any further traffic over the network, and that basically is creating a tunnel. Like it is like an encrypted thing, and now any command passed from the client will receive to the server through that secure channel using the symmetric key. Okay, coming to the last bit, some thoughtful question. Okay, so let's say, because given the session key and the secret key was exchanged start using the Diffie-Hellman, then why are we doing the mutual authentication again? So basically what I meant here, so here we are getting the session key and we need only the session key to basically connect from the LS and the remote host securely. So why are these steps needed? Okay, so to answer this, if you read about like Diffie-Hellman key exchange, so Diffie-Hellman basically is susceptible to man in the middle attack. So this will be like Eve, he can intercept the traffic and basically become like it does not authenticate fully. So Bob will not know like I'm authenticating Alice. Alice will not know I'm authenticated Bob. So they have no knowledge, but they have just shared the secret key. So a secret key can be shared between Alice and Eve and Bob and Eve, and they will try to communicate. So in order to prevent this man in the middle attack in Diffie-Hellman, so we are using RSA. So RSA will then use a public key and private key cryptography. So now let's say they have exchanged a secret key. Okay, Eve has sent a secret key like X, and to Alice it has sent like Y. Now what Bob will do is Bob will create a public key, create a message with a public key of Alice, and send it to the connection. Eve will have no private key for Alice, so he will not be able to decrypt it, so he will not be able to send it back. So then the authentication will block and the connection will be closed. Okay, so in order to prevent the man in the middle attack, we are using mutual authenticating using the RSA algorithm here. But this RSA is not fixed, it can be like DSA and any asymmetric key cryptography. Now coming to the next question. Okay, since we are using a public key private key cryptography, why not encrypt the secret key and send it? So basically what I mean, do I need this step? So if you see here, we server, if we encrypt the message with the public key, why not encrypt, instead of message, encrypt the secret key only, and both will get the secret key then. So this is possible, but the problem here is a concept in cryptography, if you read, is called forward secrecy. So Diffie-Hellman, Diffie-Hellman uses a few keys, like one is like generator, one is like primordialist, and then there is a private key. So all these are like ephemeral for uh, Diffie-Hellman. Basically, it's like use and throw. So they use it and throw it. But for RSA, this they generates a public key pair, public key, and private key pair, which they keep. So somehow, if a attacker Eve is basically sniffing over the entire packet and storing all the session which is happening between the uh, local host and the server, then if he somehow gets access to this private key, he can decrypt the entire session, right? So after a long time as well, like let's say after 2 years, he gets an access to the private key. He can get an access. Suppose like this hard drive is thrown and he get an hard drive, look into it and figure out the private key. And then if he has it stored, he can basically go back and decrypt the entire session and read all this thing. So basically this is violating the forward secrecy. But since for Diffie-Hellman, which we are using secret key, which we are generating through Diffie-Hellman, is like forward secret basically. So it supports the forward secrecy basically, because all these parties involved, like the public key, private key, all are ephemeral. So basically they are use and throw. So once generated, that will not be used again. A new public key, private key will be used. So the entire communication cannot be decrypted ever. Yeah. So this is it about SSH connection and SSH protocol. Now, since we have looked into SSH as a whole, let's talk about quickly about its advantage and the disadvantages. So basically, SSH provides us, the advantage is like SSH provides a secure channel through which one can share or transfer the data over the network. Coming to the disadvantage is basically it requires a controlled environment. So by controlled environment, I mean like every person or every host or every service should know each other. Here as well, like a user was knowing the remote host was knowing the user, right? So it will not work in the open environment like cloud and all. Apart from that, it's like hard to manage, like there are a lot of keys involved. If something is configured, misconfigured basically, it will be hard to debug, right? Okay, cool. So now I think we should end this video. Before closing, I will be happy if these explanation made sense to you. If you are able to understand the concept of a search better, please do hit like and subscribe. And if there is a issue, like if you are still not clear on something, feel free to comment. I will be happy to respond. Thank you. Bye bye.